All right, so when we're talking about osmosis, this is specifically the movement of water. We're just looking at the movement of water from area of high concentration to low concentration through a semi or selectively permeable membrane. So that means only certain things are allowed in and out. Doesn't let everything in, doesn't let everything out. So we're going to look specifically at the movement of water. So we've been looking at little containers that look something like this with a cell in it. Okay, so let's talk about the egg osmosis lab. So in the egg osmosis lab, we had 80% water inside of the egg. And in the first container, we had corn syrup. And the corn syrup was about 5% water because it's just really mostly sugar. And that's water there. Okay, so we've got a very low concentration of water here, a much higher concentration of water there. So water is going to move from an area of high concentration to low concentration. And what it's trying to do is it's trying to make the amount of water on the inside and the outside of the egg equal. So they're in equilibrium. So water is going to exit that cell, causing it to shrivel up. And y'all saw that in the video. And so this is called hypertonic. Oops. Hypertonic solution. So it's a hypertonic, so hyper exits, hypertonic solution because the water is exiting or leaving that cell. Because we've got an area of high concentration to low concentration. Okay, now if we look at another example, so let's say we've got that 80% water. Whoops. Let's try that again. 80% water on the inside of that cell. And we've got the tap water, which was about 100% water. And again, it's not 100% because there's things like chlorine and fluoride and all sorts of things inside our tap water. So it's not pure H2O, but it's pretty close. So we're just going to say it's about 100% water. So now we've got an area of high concentration to low concentration. So water's now going to go from inside this container inside that cell. So now we've got an area of high concentration on the outside, low concentration on the inside. Water's going to move inside that cell, causing it to swell. So now we get that big round cell, and that's called hypotonic solution because there's more water on the outside than there is on the inside. So think about like the hypo is like that big swell. So it makes that big circle and it swells. The third type that we're going to look at is going to be, we still have 80% water inside that cell. And now we've got 80% water outside that cell. So we've got 80% here, 80% here. It's equal. So now we have an isotonic solution. Iso meaning equal, but there's still water movement that goes back and forth and back and forth and back and forth. And so there's just little bits. It's not very much, just little tiny bits that go back, forth, back, forth, back, forth. Okay, so in your hypertonic solution, it's going to exit. Okay, so water is going to go from an area of high to low concentration. High on this one is going to be inside of that cell. Outside is only going to be 5%. Water is going to exit, causing it to shrivel. Hypotonic is going to blow up. Whoops. Okay, it's going to blow up and it's going to make it nice and big, just like we saw right here. Okay. And then, so hypotonic, we've got more concentration on the outside than the inside. And we're going to then, again, try to make it equal. So let's make it like 90-90, whatever that might be. And so water's going to move in. And then isotonic, iso is equal. We have an equal amount here. So if I were to draw this right here. And I said that there was 65% water. And here's 70% water. Okay, what direction would that water go? I'm pausing because I want you to think about it. Okay, so here we have that higher concentration to a lower concentration. So water is going to go from an area of high to low. So water is going to go in. That makes it's going to make it swell. And when it swells, it gets bigger and rounder so that it is hypotonic solution. Hypo. Okay, so if we've got here, let's stick with 65%. And let's say here we've got 50% water. All right, so now we have high concentration on the inside, lower concentration on the outside. So water's going to move from area of high concentration to low concentration to try to dilute that. So water is going to exit. If it exits, now it's in a hypertonic solution. So E exits. All right, I hope that helps. If not, we have tutoring.